Hey everybody, this is Mr. Regner, and this is our Chapter 4 practice test. You'll find it inside of your Big Ideas textbook on page 194. And so, my hope is that you'll be able to kind of follow along with this video and use it in a way that's going to help you most. So maybe you already know number 1, you can skip that in the video and hopefully get the help with the questions that you need. So let's go ahead and get started. Number 1 does say that we're going to write the fraction or mixed number as a percent. So that is 21/25. I know that as a percent, I'm looking for a number out of 100. So I want to think, what am I going to do to 25 to get to 100? I'm going to multiply that by a form of 1, and that would be 4 over 4, because 25 times 4 equals 100. So 21 times 4 is going to be my answer. So kind of quickly here, 4 times 1 is 4. And 4 times 2 is 8, so 84 out of 100. That would be my percent. I would then turn that into a percent here as 84%. For number 2, we have 17/20. Same idea here. I want to get that to be out of 100. I'm going to multiply that by a form of 1. And that's going to be 5/5, because 5 times 20 is 100. So 17 times 5, to kind of save some time here, I'll kind of do the math off to the side. But of course, we can always do the math on paper if we need to. That would be 85 over 100, or 85%. For number 3, we get our mixed number on here. We've got 1 and 2/5. Now, one thing I need to do here is actually work this out maybe in 2 different ways. That 1 I could think of, that's already 100%, right? So I could just figure out what 2/5 is and add that onto the 100%. Or I could turn this into an improper fraction, solve it that way. Whichever way you choose, I think it's maybe easiest to think of that 1 as really being 100%. So if that's 100%, let me just figure out what 2/5 would be. So I'm going to turn that into something, multiply it by a form of 1, and it's going to be something out of 100. So 5 times 20 would be 100. So my form of 1 is 20 over 20. 2 times 20 is 40. So that means that 2/5 is 40%. Guys, you might have memorized that. So you might know that already. So we have 100% plus 40%. That's going to equal 140%. That's number 3. Take a look at number 4. I sort of feel like this is going to be easy, maybe. We have 42/100. If I'm turning that into a percent, I like to think that I'm just moving that decimal to the right 2 times. That's going to be 42%. For number 5, it says 7 and 88/100. Move it to the right 2 times. I end up with 788%. For number 6, we have some crazy number here, 5854. Again, I'm just moving my decimal to the right 2 times. I get 5854, decimal there, percent sign. 58 and 54/100%. For number 7, we're taking the percent and we're going to write it as a fraction. Oh, I'm sorry, a fraction in simplest form and as a decimal. Ooh, getting tricky on me. So number 7, we have 96/100%. Important to notice that that decimal is there, right? So Beyonce loves these when we convert them into decimals. She sings a song about it. She says, to the left, to the left. So we move it over to the left 2 times. That would be, oops, that almost got me actually. That would be 96/10,000, right? Because we moved it over to the left 2 times. To convert that then into a fraction, I could think of it as 96/10,000, right? That's the same as 96 over 10,000. Now the trick is here, we need to simplify that all the way. So just kind of glancing at this, I see a common factor. It's got to be 2, right? 2 goes into both of those numbers. So I'll divide by 2, 2 over 2. 96 divided by 2 would be, I think it was 48. And then 10,000 split in half is going to be 5,000. Well, look, I can still chop this down. I can keep on going. Let me write this over here. 48 over 5,000. I'm going to, again, divide by 2 over 2. I'm just chopping away at it here. Obviously, if we find the greatest common factor, we don't really need to take that time to chop it away. We can just easily do that. We end up with 24. 48 divided by 2 is 24. 5,000 divided by 2 would be 2,500. We can keep on going, right? Divide that by 2 over 2. Kind of showing you the long method here, but I'm okay with it if you're okay with it. 2,500 divided by 2, that would be 1,250. Again, keep on going, right? Kind of showing you this because I think a lot of people will probably attack it this way, by just chopping it apart bit by bit. Half of 12 is 6. Half of 1,250 would be 625. Right? And I think, have we come finally to a stopping point? 625. Let's see, 2 doesn't go into it. 3 wouldn't work. 4, nope. 5, nope. 6, nope. 7, nope. I think that's it. So my simplified fraction there is 6 over 625. Boy, kind of a lot of work now that we're getting into these ones. Here's number 8. That looks weird, but that's number 8. It says 65%. To convert that to a decimal, pretty easy. Move it to the left, right? That ends up with 65 hundredths. Now for the fraction, that's 65 over 100 because it's a percent, right? 65 hundredths, 65 hundredths. Now to simplify. You might be thinking 5 is a number that goes into both, right? So I could divide, again, by that form of 1, or just think 5/5. 100 divided by 5 is 20. 65 divided by 5 is 13, I think. Yep. 13. So I get 13/20. That's as simple as I can go. Much easier on that one, right? Number 9, it says 25 7/10%. I'm going to convert that by just moving to the left, I end up with 257 thousandths. Just reading that, 257 thousandths, I've said the fraction form. So I have 257 over 1,000. Again, I want to think about common factors. But, you know, these are weird numbers, right? 2 is not going to work. 3, remember our trick for 3, could add up all the numbers. But that wouldn't work. 3 doesn't go to 1,000. 4 is not going to work. 5. Turns out this is as simplified as we can get. That is the simplified form. Moving on to number 10. Number 10 and 11, both of them say tell which one's greater. So we have 16/25 or 65%. What I'm going to do is convert those so that they're all the same. And I think I'm going to take my fraction in this case and convert to a percent. I'm going to do that by multiplying by that form of 1, and that would be 4 over 4, because 4 times 25 equals 100. To make a percent, I want the bottom denominator to be 100. 16 times 4, that would be, I'm thinking of my 8 times 8 would be 64. 16 times 4 would be 64 as well. So my percent here is 64%. As I compare that to 65%, the bigger number is 65%. There you go, number 10. Moving on to number 11. Again, I have a percent, but now I have a decimal. Again, I think it's easy to convert maybe the, either way, really. I'm going to go percent and convert that into a decimal. Beyonce says to the left, we end up with 56 hundredths. Since 56 hundredths is smaller than 5 6/10, I'd say 5 6/10 is bigger. Let's move on. Take a look at number 12. It says order the numbers from least to greatest. Now, there's always a little bit of time we have to invest in questions like these because we're converting them all. I suggest making them all percents, making them all decimals, or maybe making them all fractions with common denominators. Honestly, I would not steer you towards fractions. Since I have a percent and a decimal, 2 fractions, it really doesn't matter. I'm going to make them all percents. So I have 85%. I have 7/10. I have 74 hundredths. and I have 4/5. So 85% becomes 85%. No change. 7/10, I know that one is 70%. 7/10, I could inflate that, multiply it by 10 if I wanted to. 74 hundredths becomes 74%. And 4/5, I've actually memorized this one too as 80%, but I could do the math there if I needed to. So now putting them in order from least to greatest, the smallest is 7/10. Then next would be 74 hundredths. Then we'd have 4/5. And finally, we'd have 85%. That's the order from least to greatest. Moving on to number 13. We have 130%. We have 1 32 hundredths. We have 6/5, 5/4, and we have 1 28 hundredths. Again, I like percent, so I'm going to stick with it. 130 becomes 130%, no change. 1 32 hundredths becomes 132% because I moved that decimal to the right 2 times. 6/5. Now I know my fifths are all 20s. 1/5 is 20%, 2/5, 40%. So 6/5, I know this, is going to be 120%. If I didn't know that, I could always work it out mathematically, right? 5/4, I know my fourths are all going to be 25%, right? 1/4 is 25%, 2/4 is 50, 3/4 is 75, 4/4 is 100, and 5/4 would be 125%. Draw these little arrows to make sure I'm not lost. And then 1 28 hundredths would be 128%, because I just moved that decimal to the right 2 times. So now let's put them in order. Let's see, smallest one, it's got to be 6/5. You might even mark that off when you're done with it, so you don't miss it or something. The next one is 125%, which is 5/4. The next one is going to be 128%, which is 1 28 hundredths. The next one's got to be 130%. And the last one is 1 32 hundredths. X, 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 X. I got them all. There's my order from least to greatest for number 13. Let's move on. Take a look at number 14. Number 14 says 80% of 90 is what number? Well, that's not a big deal for me. I'm just going to take 80% of 90 equals something. I'm going to convert 80% to the left, move that over. I get 8/10. Of means times. So it's really just 8/10 times 90. I can do that. Watch, here I go. 90 times 8/10. 8 times 0 is 0. 8 times 9 is 72. I've got one place value over, so my answer here is 72. 80% of 90 is 72. Let's move on to 15. It says 120% of 75 is what number? So I convert. 120 becomes 1 2/10 of means times, and 75 stays the same. Now I multiply. 75 times 1 2/10. 2 times 5 is 10. 2 times 7 is 14, plus 1 is 15. Add a placeholder 0. 1 times 5 is 5. 1 times 7 is 7. Add them together. 0, 0, 7, 8, 9. That's 900, but wait, there's a decimal move. So my answer here is 90. Moving on to number 16. It says 40% of what number? Is 34. So 40% of blank equals 34. Now these are kind of the trickier ones, remember. So there's a couple ways we could think of this. We could maybe make a ratio table if we wanted to. We could maybe use algebra to solve. If we do it algebraically, we know we're going to take 4/10, because I converted the 40% to a decimal, of means times. We have a blank space. I'm going to call that letter A. We know it's going to equal 34. To get A alone, I'm going to divide away 4/10. Divide away 4/10. These cancel out. I'm going to have just A, and then 34 divided by 4. I could do that over here. 34 divided by 4/10, I should say. Move my decimal over, add the 0. 4 goes into 3, doesn't. 4 goes into 34, does. We'll say 8 times. That's 32. Subtract, get a 2, bring down to 0. 4 goes into 25 times. 5 times 4 is 20, and my remainder is 0. So A equals 85. That's the algebraic way of solving that one. All right, so for number 17 now, we have 130% of a blank number is 52. For this one, I think it may be tricky, but I'm going to show you the ratio table. We know there's a part to whole for every percent. In this case, 130% is 130 out of 100, right? I'm going to try to figure out what the whole would be if the part is 52. In other words, I'm going to make an equivalent ratio in this case to solve this, using this ratio table to help me organize it. So I can't take 130 and just turn it into 52. There's no reasonable way that that's going to happen, but I can break down these numbers, and that's why I have this space in the middle. So I want to think about 130, or maybe even 13, and how it relates to 52. This is not a common number that we use, so you may have trouble seeing it. That's where we can always go back to that algebraic way of solving it if we need to. But I know I can break down 130 and into just 13 by dividing by 10, right? Same thing here needs to be done. Divide by 10. That gives me 10. This is the same ratio. 130 to 100 is the same as 13 to 10. Now, hopefully, you may have thought this one through, that 13 times 4 equals 52. And it does. So that means we could take 10 times 4, and it would equal 40. So 130% of 40 would equal 52. And we use the ratio table to solve this. If the ratio tables work, you're welcome to use them, but you know you can always use the algebraic way as well. Let's move on. Get to number 18. Word problem time. It says a goalie's saves and goals scored against are shown. That sounds confusing when I just read that. All right, so we've got dots here. The dots represents the saves, and the X's represents the time that they're scored. What percent of shots did the goalie save, and explain? To answer this one, I'm going to make a little chart for myself here. We've got the saves and the goals. I need to count them up, right? And so this is one where we really have to make some make the visual clear on the videos. Let me see if I can zoom in here. Obviously, in your own book, it may be the easiest to see it, but I'm going to attempt to count these out. And my camera's not cooperating with me. So let's see if I can do this. I'm going to count the saves first. So the dots. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now you may want to count that twice just to make sure you got them all. But I counted, and I'm thinking I'm going with 14. For the X's, in other words, the times they were scored upon, we want to count those up. So let's see here. I have 1, 2, 3, 4, 5, 6. There were 6 of them. Let me zoom back. Let me just remind you also that there's some dots on the hockey rink there that don't actually mean that those were times they were shot. Like these little dots here are not the same color. There's some dots in the middle, not the same color or size. So watch those very, very carefully to avoid making errors. So the question again, it said, what percent of the shots did the goalie save? Okay, so we want to figure out the number of shots that were saved. That is the dots, right? So there were 14 saved. Again, I'm going to write down this as a part to whole, right? We know we want to come up with a whole part that is 100. If I make this like a ratio table. And we know that in this case, there were 14 saved. That's the part. The whole is going to be 14 plus 6. That means there were 20 shots total. So we could, I guess I didn't really need that middle part. I could just take 20 times 5 and get to 100. So 14 times 5 to get my answer. For this, I always think 7 times 10 because 14 is 2. I don't know if that helps you out. But I end up with 7. 70 out of 100. That would be 70%. Now we could have also just done 14 divided by 20, gotten a decimal answer, and that would have been 70% also. All right, that is number 18. Let's move on and take a look at number 19. 19 says, and I hope you can read it, maybe in your book if you can't see it here in the video, it says about 62% of the human body is composed of water. Write this percent as a fraction in simplest form. So this is really kind of like what we did in number 7, 8, and 9. Right? We have 62%. We're going to write that like a fraction. That's 62 out of 100. To simplify that, I want to come up with common factors. So again, maybe I'm going to divide that by a form of 1. And maybe I'm going to go 2 over 2. Right? 62 divided by 2 is 31. And 100 divided by 2 is 50. I can't simplify it anymore. Just 31/50ths. That's number 19. Number 20, I think I'm going to give myself a new page here for this one, just to make sure I have plenty of room. Here's number 20. It says you, your cousin, and a friend each take the same number of free throws at a basketball hoop. You make, let me make a little chart here. You make 17/20ths. Your friend, your cousin makes 8/10ths, and your friend makes 87 5/10% of their free throws. Who made the most free throws? All right, so we just basically are comparing these. I'm going to compare them by getting them all on the same level. So I'm going to go with percents again because I like percents. So this one, 8/10ths, I'd move my decimal to the right 2 times, becomes 80%. And then 17/20ths, I could divide. 17 divided by 20, I'd get a decimal answer, and I would get my answer that way. Or maybe, I can't really simplify this one. Maybe we could inflate it, right? 20 times 5 is 100, so 17 times 5. Anyway, we look at it, if we convert this over, we're going to end up with 85%. I know I didn't really show the work there, but that would be the way we do it. Who scored the most? That's got to be 87.5%, your friend. For number 21, it says, in a class of 20 students, 40% are boys, 25% of the boys and 50% of the girls wear glasses. How many students in the class wear glasses? What? That sounds confusing, right? So we've got to just kind of break it down and make it simple. So there's 20 students, okay? In a class of 20 students, 40% are boys. So 40% of the 20, right? That means we're going to take 4/10ths times 20. That's just going to tell us how many of the how many boys there are in the class, right? So let's work this out. 4 times 0 is 0. 4 times 2 is 8. That one decimal move over. That means that there's 8 boys. Now remember, there's 20 students, so we also can know that there are 12 girls. Again, we just did some math there to figure that out. So it says 25% of the boys and 50% of the girls wear glasses. So let's figure out what is 25% of 8 and then 50% of 12. Some of you are probably going to look at this and say, well, 50% of 12, that's an easy one. It's just half. That's 6 girls. Some of you might be able to do this with 8 as well. 25% of 8. If you just think about breaking 8 down into 4 parts, right? Hoping, maybe, yes, no, it would be 2. I don't want to surprise you guys. Again, we could do the math there. If you're confused on that one, I could take 25/100ths times 8 or 5/10ths times 12 and get those answers. So how many students in the class wear glasses? That would be 2 plus 6. There's 8 students that wear glasses. For number 21. Let's move on and take a look at the last question. Oh, final question. So sad. It's number 22. If I can get my new page out. There it is. Number 22. Another visual aid for us here. I'll try to move my book up as far as I can. There it is. It says 80% of the picture frame is glass. What is the area of the molding? What? Okay. They're trying to get all fancy with us here. The molding would be this white part around. It's even labeled molding. What we need to do is figure out then what is the area of the whole thing, the whole entire picture. And we know 80% is glass, so we know 20% is going to be the molding. So we're going to figure out what 20% of the entire area would be. So let's do that. First, we should know that area equals length times width or base times height. we're just going to take our 2 dimensions and multiply them. So I'm going to do that right now. I have 8 1/2 times 10 3/4. And I realize I probably just wrote that backwards, but it wouldn't matter whether you multiplied one first or the other first, because in multiplication we can switch them around. It's called the commutative property. In this case, I've got fractions. I can multiply fractions. I'm not scared of doing that, but I also could convert them if I wanted to, right? In this case, I don't know, just for fun, I'm going to convert them. I'm going to convert them into decimals. So 8 1/2, that's going to be 8 5/10. And 10 3/4, that's going to be 10 75 hundredths. I'm going to set it up as a multiplication problem because I'm multiplying to find the area. Notice I didn't care about the decimals. They're not lined up. I'm going to worry about those later. 5 times 5 is 25. 5 times 7 is 35 plus 2 is 37. 5 times 0 is 0 plus 3 is 3. 5 times 1 is 5. Add a placeholder 0. 8 times 5 is 40. 8 times 7 is 56 plus 4 is 60. 8 times 0 is 0 plus 6 is 6. 8 times 1 is 8. Add these together. 5 plus 0 is 5. 7 plus 0 is 7. 3 plus 0 is 3. 5 plus 6 is 11. 8 plus 1 is 9. I've got 1, 2, 3 decimal moves. So 1, 2, 3 decimal moves. The entire area is 91 375 thousandths inches, or square inches, I should say. So I want to figure out what is 20% of this amount, because 20% represents the molding. So let me go ahead and do that. I'm going to take 20%, convert that into a decimal. That would be 2/10. Since it says of, I'm going to times. So I'm going to take 91.375 times 2/10. Could have done 20 hundredths as well, but I like 2/10. 2 times 5 is 10. 2 times 7 is 14 plus 1 is 15. 2 times 3 is 6 plus 1 is 7. 2 times 1 is 2. 2 times 9 is 18. And I've got 1, 2, 3, 4. 1, 2, 3, 4 decimal moves. So the molding is 18 275 thousandths square inches. The area of the molding is 18 275 thousandths square inches. That's number 22. Guys, we went through this kind of quickly, but at the same time, it took a long time. Hopefully you can use this video to help you out. If you have questions, please feel free to contact me.